mutually exclusive events. This is the last thing that's on the quiz. And then your rest of your time will be to start the homework, which I'm going to be honest with you, the homework is not easy, and I need to see fractions. So, and I shouldn't say not easy. They're big numbers. That's the only problem with the homework. And I want to give that to you because that's how the test is. The test uses big numbers, whereas I think this worksheet is actually more simplified. So let me explain real quick what mutually exclusive means. When you're mutually exclusive events, they are two events that cannot happen at the same time. And so the first part of your homework will actually just to be determined if something is mutually exclusive or not mutually exclusive, which they call inclusive. I hate using that because it confuses me over and over again. So I actually use the phrase mutually exclusive, ME, and not mutually exclusive. So don't just put yes, no. Put like ME or not ME. I think if you understand it because you're a wordy person, so you understand inclusive, not mutually exclusive, whatever, go for it. But for me, I'm not a wordy person, so I have to do it my way. But this will be the first part of your homework. Determine if the events are mutually exclusive. And let me just give you a couple examples here. A person with type O blood and a person with type A male student and a senior student. You probably can figure out what these are right away. A face card, a 6 card, and we'll do one more. A queen, and a heart. Okay, so again, I'm looking to see, are these happening at the same time, or can they happen at the same time? If they can, then they're not mutually exclusive. If they can happen at the same time, they cannot happen at the same time, then they're ME. They're mutually exclusive from each other. So this is where it gets, kind of have to say this over and over again in your head. You want it to be mutually exclusive. You want it to not happen at the same time. So a person with type O and a person with type A, can that happen at the same time? Can you have type O and type A? No. So this would be ME or not ME. This is ME. It's not happening at the same time. A male student and a senior student, can that happen at the same time? Yes. So are you ME? Not ME. It can happen at the same time. I have to write this. I'm telling you, like in the beginning, I have to write this so it kind of ingrains into my head over and over. ME cannot happen at the same time. Not ME can happen at the same time. So how about a face card and a 6 card? Can that happen at the same time? No. So this would be ME. It cannot happen at the same time. How about being a queen and a heart? Is there a queen of hearts? Yes. Yes. So that is not ME because it can happen. Doesn't that seem weird? It's like the logic seems weird. It's not ME, meaning it can happen, right? Because it's not happening. Very weird, but can happen. All right. Now, what does this do for us? Well, we are now going to be introduced to a new rule. It's called an addition rule. And I use it actually for everything that is. I use it all the time, whether you're ME or even if you're not ME. I use it for everything. And it makes more sense if I just use it for finding the probabilities of two events. It's called the addition rule. And it says that A and B are not mutually exclusive, but I still use it if they are. the probability that event A and, oh, I'm sorry, not end. That's a very important word. Or B, the probability that A or B occurring at the same time would be the probability of A plus the probability of B minus the probability of A and B. And again, I use this for both ME and not ME. Use it for both. Use it for both, okay? This end, remember it's that intersection where they overlap, right? That's the and part. So we have to take that away. So think about it. If I said, find the probability of being a queen and a heart, or a heart, you'd have to find the probability of being a queen. You'd have to add that to the probability of being a heart, but then you'd have to take away being a queen and a heart because you've already double counted it. So that's why this works for everything. I would use it all the time for everything I got. All right, let me flip this over and we'll do a quick example. We'll do that sheet together too. All right, so we're going to talk about good old deck of cards because I do love them. Probability of picking a 6 or a king, and then the probability of picking a 6 or a diamond. All right, so we'll do both of these together so you can understand how to solve these lovely fractions. So again, the rule when you see or, when you see that word or, is you take the probability of the first guy as a fraction, add it to the probability of the second guy, so this would be the probability of 6, add it to the probability of being a king, and take away the probability of being a 6 and being king. Now, what's the probability of being a 6?
4.
There's 4 6s out of how many in the deck of cards? 52. What's the probability of being a king? 4 kings out of? Can you be a 6 and a king, though, simultaneously?
No.
No. So that's why I still like to use this, because even though you're like, that can't happen at the same time. I know, that's great. But it still works. It still helps me out, and still I get the problem correct. So what is that answer right there? 8 out of 52, right? Which would reduce to like 4 out of 20, which is what? 2 out of 13. So either, I actually like this. This shows me that you know what you're doing, if you can kind of do that. Now this one can happen at the same time, right? You can be 6 and a diamond. And so we have to take away that we've double counted it. So that's why I would say, all right, probability of being 6, probability of being a diamond, and then minus the probability of being a 6 and a diamond. I'm running out of room there. So what's your chance of being a 6? 4 out of 52. We know that one. How about being a diamond? How many diamonds are there in the deck of cards? 13 out of 52. How many 6 diamonds are there? 1. So we have actually double counted them, so we have to take it away, because this is happening at the same time. This is not mutually exclusive, so that's why we need to take that double count away. So 4 plus 13 is 17. Take away 1 is 16 out of 52. What is that? 8 out of 26, 4 out of 13. Does that make sense? We want to, like I said, I use this formula every time I see the word or. So that's the key. First of all, it's only used for the word or, only. And you use it every time, because you'll always get the answer right, whether it's mutually exclusive or not mutually exclusive. This was mutually exclusive. This was not mutually exclusive. I think it just, like, I don't care what it is, just do the thing every time you see the word or. All right, so now take out this little crazy sheet together, but we're gonna kind of work through a bunch of them. And that way you'll have 1/3 of your homework done if you do it with me. And they drew out the cards for everybody because there's people in here that don't like cards or understand cards, so I'll help you out with it. What's the probability of randomly selecting a card from a standard 52 card deck and having a card be black or, see there's that word or, face card, okay? So this is what I do anyway, I just say probability of being a black card plus probability of being a face card, and then what do I take away? Probability of being black and a face card. Okay, so you just write some fractions. What's your probability? And I wish this was color for you, but these are the black cards up here, this top row and then down here. So there's how many black cards?
26.
26 out of 52. I got to move up here. How many face cards are there? 3, 6, 9, 12, right? Ace is not a face. So 12 out of 52. How many black face cards are there?
6.
Out of, okay. So how much would that leave me with? 38 minus 6 is 32 out of 52. By the way, were these mutually exclusive or were they inclusive? Were they happening at the same time or can they not happen at the same time? They can happen at the same time, which makes them what we call inclusive, but I hate that word. I just like not Emmy.
So we're not supposed to reduce it?
Just leave it like that, but you could reduce it if you want to. All right, try number 2. If it says that word or, then you do this formula. If it says find the probability of this or that, use this formula. This plus this minus the both of them happening. Okay, so find the probability of picking a face card or an odd numbered. How many face cards are there? 12 out of 52. How many odd ones are there? I didn't get 21. 16 is what I have here, yes. Minus, what's the probability of being face and odd? Can you be a face card and an odd card? No. So that would be 0. So this would be mutually exclusive because these don't happen at the same time. But you would have 28. No, sorry, my bad. 28. Said I can't count out of 52, which obviously reduces. All right, how about probability being an even card? Being an even card, 20 out of 52. What's the probability of being red? That's half your deck, correct? So that's, oh, red numbered, my bad. Oh, shoot. Yay, thank you for that. I know, I really went red numbered. So being red numbered, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then another 9 would be 18 out of 52. Thank you. And then take away being even and red numbered. So that's 10 out of 52. Good job. That was my bad. So 38 minus 10 is 28 out of 52. So this one was weird. You have to have a couple things with you. You have to be a heart with a number on it. How many hearts are there with numbers on them? 9, right? Out of 52. For this one, you have to be a spade with a letter on it. Here's your spade, including the ace has a letter on it. So that's 4 out of 52. Can you be a heart with a number and be a spade with a letter? No. So these are obviously mutually exclusive. They can't happen at the same time. So that would be 13 out of 52. Hopefully this is kind of making sense. It's just the same thing over here. Following shows a Venn diagram with the results of a survey a teacher gave to all her students. It represents where all the students have gone to eat over the last month. What is the probability of following? What is the probability of randomly selecting a person from this group and picking the student has not eaten at any of the restaurants or they ate at McDonald's? So I want the probability that you have not eaten at any of the restaurants plus the probability of eating at good old McDonald's, Mickey minus the probability of not eating at a restaurant and being a part of McDonald's, which obviously you all know cannot make sense right now, but that's okay. We understand. How many people are not eating at McDonald's? Or not eating at a restaurant? I'm sorry. 17 out of, I'll tell you the total. There's 90. How many people ate at McDonald's? Remember, you have to be a part of the McDonald's circle. How many? 7 only ate at McDonald's, but if you ate at McDonald's, you would be a part of this circle. So how many is that?
23.
Yes, sir. And then obviously, if you're not eating at a restaurant, you wouldn't be eating at a McDonald's anyway, so that would be a 0 here. So 17 plus 23 is 30. No, 40. Mrs. said I cannot count this morning. 49, 4/9. You're in the McDonald's circle. There are 23 out of 90. We already found that. Add that to how many are in the Chick-fil-A circle? How many? 37? Okay. Take away the people that have been double counted and already ate at McDonald's and ate at Chick-fil-A. That would be this football section right here, which is 10 out of the 90. And that would be 50 90ths. Okay? So you're doing good. This idea of mutually exclusive. Okay? I know, it looks daunting, but we can get this done. What is the probability of rolling 2 dice and getting a sum of 4 or getting a sum greater than 10? We'll do this one together and then you can try to do 7. Getting a sum of 4. So someone help me out. Where's all the sums that are 4? How many sums of 4 are there? 1 and 3. There's 3 out of
36.
Yep. Now find the probability of getting a sum that's bigger than 10. So where am I bigger than 10?
There's 3.
Wait, is it like 10 or greater?
Greater than 10. So 6 and 5, 5 and 6, 6 and 6, right? Is that it? Which is how many? 3 out of 36. Can you be a sum of 4 and be greater than 10 at the same time? No. So your answer is 1 out of 6. Well, 6 out of 36, which is 1 out of. All right, do 7. Same idea. Let's talk this one through. How many even sums are there?
18.
18? Wow, y'all got that pretty good. Yeah, 1 and 1, 5 and 1, and then you just keep going. 6 and 2, 4 and 2, 2 and 2. Oh, I'm missing that one. But I do agree with you. I wrote it down before. It's 18 out of 36. I don't feel like adding in it. How many greater than 9 sums are there? Greater than 9. Yes, because you would include the 10. So this one, this one, this one, this one, this one, and this one. That would be 6 out of 36. Out of all of those, how many of those sums are even and bigger than 9? So really, it's just out of these guys, right? Which one of these are bigger than 9? 3 or 4?
4.
I think there's 4, right? Bigger than 9. 1, 2, 3, and even. So it has to be 10, 10, that's 2, and 10, that's 3. That's 11, that's not even. That's 11, that's not even, and 12. So 4 out of the 36, which is 20 out of 36. Okay. I'm actually going to do something really nice for you, which I have not done in the years prior. I always make my students do page 206, and I'm not going to because you've actually been kind of following along. This is your first homework. Your second homework will be to do the study guide. That's it. You don't have to do the page 206, but you've got to follow along with 8 and 12. 12 is going to be on the quiz. So you really have to pay attention when we go to 12, okay? You're welcome. That's okay. You don't have to say you're welcome. Jeez, Luis. Just kidding. I still love you. All right. Please consider the Venn diagram. They gave you this crazy alpha symbol, or I think it's alpha, or maybe it's omega. I think it's omega, actually. Never mind. Find right now the probability of picking from this Venn diagram. Picking A. What would you say? Would it be the 0.3, 0.2, or the 0.3 and the 0.2? What would you do? 0.5. You have to do, if I say what's the probability of picking A, wouldn't you agree it's both of them in that circle? Okay, 0.5. I'll do another one with you. Probability of picking A and picking B. Remember, and that little upside down is the overlap. So which one is that? 0.2. Remember, the word or is the combination of the two of them,
0.6.
which would be 0.6. This is a new little symbol for you, but it means the same as A prime, which is the complement of A, which is you find A and you take away one whole from it. So you subtract 100% essentially. So we already found A, didn't we? 0.5. Take away 1 from 0.5. What are you left with? 1 minus 0.5 is? There you go. Was the probability of A and the complement of B. So again, this is the overlap. This is where coming into play of those pictures that we did on that last Venn diagram. Where does A overlap B? Oh, the not B, I'm sorry. So here's picking A. I'll do it with my colors. And here's not picking B. With that crescent moon. So where would their overlap be?
0.3.
0.3. That's where the two colors I have are. See if you can figure out, and if it's hard for you, it's fine. Now you're going to do this one. F, G, H, I, and J. You're using this one. .4. And remember, that means where they overlap. Are they overlapping?
No.
0. Or means uniting them, combining them. Which would be 0.9. The complement of C, which means everything that's not in the C circle, which is a total of how much?
0.6.
Good job. And the complement of C and the complement of D, where they overlap. 0.1. Nicely done. Oh, very good. All right. And then last but not least is this question right here, which I'm actually going to have to draw out for you probably on this piece of paper here. And then this will be the first part of your homework, which you're now done with. You just have to we'll do the study guide, and you should be fine. Jason asks each member of his class what type of phone they have. The class consists of 12 women, 8 men. 5 of the women said they have an Android-based phone. 4 of the men said they had an Android-based phone. What was the probability of randomly picking a student in the class that is a man or that does not have an Android-based phone? Android. I just said Andrew. Props. Okay, so here this can get confusing. This is where we can use those two-way tables that we've talked about. Or you could make yourself like a really crazy Venn diagram, which it's up to you. I mean, some people like it, some people don't. I think I'm going to try making a two-way table on this one. I've done it with not making it. All right, so what do I have here? I have male, women, and men. Would you all agree? Okay. So, men, women. And then I want a total column. And out of those men and women, what am I basing this on? What do they have? People that have what?
Android.
Android or what else? What would be my other choice here? Other. We'll call it other. I like that. And you're going to have to get totals here, here, and here. So what we're doing is we're creating what's called this two-way table. Okay, so let's try to fill in this two-way table together, and then we'll answer the question. The class consists of 12 women. So where do I put 12? Where would you put it? The bottom middle, yes. And 8 men. Where would I put that? Right here. What's that total then? 20. So would you agree there's 20 in the class? Okay. Now let's answer this part, or let's fill in this bit. 5 of the women said they had Android-based phones. So 5 women have Android. So you're going to put 5 here. Would you agree?
Yes.
Could you tell me what would go here then?
4.
7. 5 and 7 make 12. Okay. 4 of the men said they had Android-based I keep saying Android-based phones. So 4 goes where, everybody?
Fours.
Right here, right? 4 men with Android. So what would you say with other? 4. That wasn't hard, right? It's not hard when you kind of set it all up for you. Now, add those across. How many total people have Android phones? 9. How many total people have other phones? 11. 9, 11 do make 20, okay? Now we're going to answer the question together. What is the probability of randomly picking a student in the class that is a man? So we want the probability that he's a man, or, there's that or word, so I'm going to plus, he does not own an Android phone. So probability that man, he has to be a, whoa, sorry about that.
But is it person or man?
That's a person, actually. That does not own, good question, actually. Now I'm a little stumped with myself. Because I would say he'd have to be a man not owning an Android phone.
That is a
Man,
I think it's a person.
It's a person.
it's just a person not owning Android? Yes. And then we want to take away, that's it. Thank you. Took me a moment. Man with Android. With not Android. Because we're doing not Android. This is sucky. I know, that's why we're doing it together. With not Android. Okay, so what's the probability of being a man in our little diagram here? 8 out of 20. What's the probability of owning an Android? Or not an Android, that's why I have that little slash right there. 11 out of 20. Thank you for everybody clarifying me. And then what? We want to take away that you are a man and you don't have an Android. You are a man and you don't have an Android. That is 4 out of 20. Woo, that took me a minute. So that would be a total of, what do we got? 15 out of 20. That is my answer. Good. We got that right. Yay for us all together. So 0.75, 3/4 the class, yes. All right. Tricky stuff, but that is called mutually exclusive. You can actually do mutually exclusive with 3 events. That was on the homework, but you're not doing that. All right, so no need to do because you were good. But you got to do that. Okay? And you are allowed a note card.
Am I gonna use it?
Are you going to use that note card? You better.
Can you get extra credit for this?
Can you get extra credit for doing page 206?
No, for stuff.
Yeah.
You,
Yeah.